You don't know how Hyperloglog works in this day and age? Let's say you build a streaming website and you want to know how many unique viewers you have. The most obvious approach is to store every visitor's user ID in one massive set. When someone visits your website, you check if their ID is already in the set. If it isn't, you add it. If it is, you do nothing. Simple, right? But what if you have tens of millions of unique viewers? Now, every time a new viewer joins, you have to go through a million rows to ensure that the user is unique or not. That's quite a slow and expensive thing to do when you have millions of people joining your website every single second. That's where Hyperloglog comes in. Here's how it works. Every time a user connects, you hash their IDs, which gives you a binary string of zeros and ones. Let's look at this string more carefully now. Since this is binary, the starting digit of the hash can be 0 or 1, meaning that there's a 1 in 2 chance that the first digit of a hash can be 0. But what are the chances of the first 2 digits being 0? The chances would be 1 in 4. For 3 digits, it would be 1 in 8, and so on. Notice the pattern? The more leading zeros a string has, the rarer it becomes. So instead of storing millions of user IDs, what if we just keep track of the maximum number of leading zeros we've ever seen from a hash? If the longest streak of leading zeros we've ever encountered is 5, we know that we've likely seen a hash that only happens 1 in 32 times. That means we can estimate that we've had about 32 unique viewers. But here's the catch. Imagine you get incredibly unlucky. You have 10 viewers, but one of them happens to generate a hash with 15 leading zeros. Suddenly, your website says that you have 32,000 viewers. You get excited, quit your job, and buy a ring light to become a full-time streamer, only to realize,
congratulations, you played yourself.
So how do we fix this? We take 4 buckets. Each hash is assigned to a bucket depending on its first 2 bits. If a hash starts with 00, it's assigned to bucket 1. 01 goes to bucket 2, 10 goes to bucket 3, and 11 goes to 4. After that, we figure out how many continuous zeros there are from the third bit and store that number in the bucket the hash is assigned to, but only if it is greater than the bucket's current number. Let's take an example. Using the first 2 bits of this hash, we can say that the hash belongs to bucket 2. And since we have a continuous string of 5 zeros from the third bit, we store 5 in bucket 2, and we keep repeating this for every user. Now let's take a look at this hash. It belongs to bucket 4, and it generates a hash with an absurd 15 zeros from the third bit. It's clearly an outlier, but the benefit of having multiple buckets is that each bucket now keeps its own independent account of how many unique viewers we might have. So instead of relying on a single bucket, which might have an absurd value, we average them out to balance out the outliers. But we can't just take a simple average. That would still give too much power to that one outlier bucket. Instead, we use harmonic mean, which penalizes the outliers so that they don't skew the results. After figuring out the harmonic mean, we multiply it by the number of buckets and apply a bias correction to get our estimated viewer count. Although it's not a precise number, an estimate with a 1 to 2% margin of error is more than enough in most cases. And the best part, instead of storing gigabytes of user IDs, Hyperloglog lets you count millions of unique viewers in just about 12 kilobytes of memory.